Hey everyone, welcome back to another Logs.io training session. In this video, we'll be talking about the rate function and how it works with counter metrics. If you haven't checked out my last video on the 4 types of metrics, I definitely recommend giving that a watch as a precursor to this video. Now you may be asking yourself, why are you only going to be talking about counter functions and specifically the rate function? I believe it's important that we break down this function into as simple terms as possible because it can kind of get confusing when reading the documentation if you don't have prior knowledge of Prometheus or how PromQL works under the hood. For example, maybe you just want to know if a process is running all the time at any given moment, or ensuring that your company hasn't violated any SLOs or service level objectives by tracking the current rate of requests. Whatever the use case may be, rate is a super powerful function that you can use within Prometheus. What's so awesome about rates is that it has a brilliant way of handling counter resets and making inferences to avoid incorrect calculations. So let's take a look at the syntax and break down what this looks like in PromQL. So if we look at a rate function up above, you'll see that the function looks like rate, parentheses, metric name, and range vector. Metric name obviously being what you're sending into Prometheus or into Logs.io. And then rate is the function we're calling on it along with the range vector. Now, without getting too much into range vectors, it's important to know 2 things. Range vectors are simply a representation of the window of time you're querying across. So if you want to calculate a range vector of 5 minutes, you would just use 5 minutes. Very straightforward. The other important thing to note is a range vector must be 2 times your scrape interval. So, for example, if you're sending metrics using Telegraph or OpenTelemetry or any other method, you'll probably have a scrape interval of 15 seconds or 30 seconds. However, if you have a range vector in your query that's saying, okay, I have a 15-second scrape interval, let's use a 15-second range vector, you're prone to having missed scrapes and errors. What you don't want is to use a range vector too small. So 2 times the scrape interval is the absolute minimum I would use. There is no silver bullet when it comes to range vectors, but it's important to note that 2 times should be the minimum. Now, let's take a look at a simple graph here that's calculating the total milliseconds of a CPU process. You can see on the y-axis here that we have the total processing time in milliseconds. On the x-axis, we have time in seconds. And then we have our data points or our time series plotted over time. So you can see at 15 seconds, we have 4. At 30 seconds, we have 6. And then 45 seconds, we have 10. And then at 60 seconds or a minute, we have 2. So you can see this is a very basic line graph. And by default, we're not doing anything right now. We're just getting the metric value. Now, what's awesome about rate is how this extrapolates the data and makes inferences. So you can see when we're at 10 at 45 seconds, we then drop down to 2. And what rate does is makes an inference. So instead of saying, okay, we're going to go 10 to 2, we're just going to actually add the data point that drops down, which is 2, to the last data point, which is 10. So then this becomes, on our new graph, 12. So 10 plus 2 is 12, and then it handles the reset value. In this case, the reset would be the hard decrease that we see here from 10 to 2. Now, let's look at how rate is actually calculated. Once we make this extrapolation where we say, okay, we drop down to 2, let's just add it to 10 to infer 12. Now what we're going to do is we're going to calculate the rise over run, going back to the old school days, of the slope, essentially, of our total millisecond CPU process time. Now, what we're doing at this point is rate is saying, I only care about the first data point and the last data point of my range vector. In this case, 1 minute. So we're looking at from 0 to 60. Now, at the beginning, we obviously know it starts at 0. But at 60 seconds, we have 12. So what now we're saying is, what is our rate? let's go rise over run, 12 divided by 60, 0.2. So now per second rate is 0.2 within this frame. So that is how rate's calculated. It extrapolates data depending on if there's decreases, brings it up, calculates that with the last data point, then takes the first data point and the last data point in that range vector window, and then calculates the slope. So now knowing what rate is and how it is calculated, we can move on to what rate is versus an increase. So you might have heard of the increase function within Prometheus, and it can be a very, very useful function because essentially what it calculates is the current value minus the value from the beginning of the range vector window. So if we look here, if we were calculating a 10-minute range vector, you would see that we would have up to 18 at 10 minutes, and then at 1 minute we would have 0, so it would be an 18 millisecond increase based on our y-axis. So very straightforward. We're just calculating the increase from the beginning of our range vector to the end of our range vector. Now let's talk about how this is different from rate. So if we look at this graph here, you can see that we have data points at 3 minutes, 4 minutes, and 5 minutes, 4, 6, and 8. So if we have a increase window of 3 minutes, let's say starting at 2.5 minutes to 5.5 minutes, we don't have any data points by default. So what increase does is it actually makes an inference of where that data point is based on the boundary of our range vector or our window. So now it's saying, okay, we're looking at 2.5 minutes to 5.5 minutes. At 2.5 minutes, where's the data point? At 5.5 minutes, where's the data point? And it's going to make an inference and then calculate the increase based on that. However, this can result in decimal values or floating points. So it's not necessarily problematic, but it's important to note that this can provide or result in non-integer values. What's great about rate is rate works on data points. So rate will take 4, 6, and 8, and then it will calculate the slope based on that. So the per second rate. Increase can make more broad-based inferences, but however, it can result in not as accurate data, and it's recommended to use rate over increase in a lot of cases. Last, we're going to talk about rate versus irate. Now, rate grabs the first data point and the last data point of our range vector. However, irate just works a little bit different, where it actually grabs the last 2 data points only. So, if we look at this graph here, you can see that the rate is going to calculate the slope based on this 4, 6, 10, 2, where it's going to bring 2 up to 12 because it's calculating that extrapolation like we talked about earlier. And then it's going to calculate the slope based on 4 and 12. Irate does something just a little bit different, where it will get the slope of only the last 2 data points. So if we had a irate window of 1 minute, it's not going to care about the first 3 data points we have here. It's only going to care about 10 and 12. So then it's going to calculate the rise over run of that single slope. So that's how irate works under the hood. It's just a little bit different from rate. Now, if you're curious about how rate works in further detail, I will link down a bunch of resources as it is extremely beneficial to look into, especially if you want to know how to make correct calculations in some of the, edge cases around rate. So if you have any questions, please reach out to support as always, but if not, I'll get you in the next session. Have a good day.